So here we're going to work some word problems and we're going to see what we have to do with each one. So to estimate the number of people in Springfield, population 10,000, who have a swimming pool in their backyard, 250 people were interviewed. Of those polled, 125 had a swimming pool, and how many people in the city might one expect to have a swimming pool? So what we want to do is we want to put the number who have a swimming pool over the total number of people. So swimming pool over the total people. You want to have your top and your bottom of your fractions the same. So the total number who were asked if they had a swimming pool were 250. So the total is going to be 250. Those who had a swimming pool were 125. And now we're looking to see how many people might one expect to have a swimming pool out of a population of 10,000. So our total is 10,000, and how many is going to be x. So here we're just going to cross multiply. So we're going to get 250x equals 125 times 10,000. So we're just doing a cross multiplication. So 250x equals 100, or 1, 2, 5, we've got 4 zeros. And then we divide by 250. And x is going to equal 5,000. So 5,000 out of 10,000 will most likely have a swimming pool. Now we have somewhere we are working together. So Sue cleans the house in 7 hours. Bob takes 9 hours to clean it. How long would it take to complete the job if they work? So I find that if you set up this chart, it makes it the easiest. So Sue can do the job alone in 7 hours. Bob can do it in 9 hours. We want to find out how long it'll take them to do together. So what part can Sue do in 1 hour? Well, she can do 1/7 of what she does. And Bob can do it in 1/9. And together they'll do it 1 out of t hours. So basically you're just putting each of these in the denominator and 1 on top. And this last column creates your equation. So we're going to have 1/7 plus 1/9 is equal to 1 over t. And now we're just going to find our common denominator. Well, 7 times 9 is 63 times t. So 63t for each term. So 7 goes into 63 9 times, so that leaves me with 9t times 1, which is 9t. 9 goes into 63 7 times, so 7t times 1 will get me 7t. My t's will cancel, and 63 times 1 is 63. So 9 plus 7 is 16t equals 63. Divide by 16, and t will equal 3.94 hours. So it'll take them about 4 hours to do it together. On the next problem, we've got a boat that moves 8 kilometers upstream in the same amount of time it moves 15 kilometers downstream. If the rate of the current is 9 kilometers per hour, find the rate of the boat in still water. So this is a rate times time equals distance. So let's look at again what we know. A boat moves 8 kilometers upstream and it moves 15 kilometers downstream at the same amount of time. If the rate of the current is 9 kilometers per hour, so if the rate of the current is 9 kilometers, that means when we're trying to go upstream, we're fighting against the current, so we're going to subtract 9. Going down, it's going to add and help our boat go faster, so we're going to add our current going down. And then they're at the same time. So we can solve for t with our d and our r, because if d equals rt, if I want to solve for t, all I have to do is divide by r. So I'll have d divided by r will equal my t. So 8 divided by x minus 9. And here I'll have 15 divided by x plus 9. It's the same amount of time, so we can set those equal to each other. So 8 over x minus 9 will be equal to 15 over x plus 9. Now we're just going to cross multiply again. So 8 times x plus 9 will equal 15 times x minus 9. So that'll get me 8x plus 72 equals 15x minus 135. Decide which way you want to move your x's and your numbers. I like to keep my x in the positive, so I'm going to subtract 8x from both sides and get 72 is equal to 7x minus 135. I'm going to add my 135 over, and I'm going to get 207 is equal to 7x. Bring this up here to finish. So 207 equals 7x divided by 7. And my x is going to equal 29.57. So how fast does the boat go in still water? It goes about 30 miles an hour. Or sorry, kilometers per hour. All right, on our next problem, we are looking at two automobiles going in opposite directions, leave at the same time. One automobile travels 20 miles per hour faster than the other, and in 5 hours, the automobiles are 650 miles apart. Find the speed of each. So they're going opposite directions, same amount of time. One travels 20 miles per hour faster than the other, so one's going to be x and one will be x plus 20. In 5 hours, that's our time, the automobiles are 650 miles apart. That'll be the total distance, will be 650. So rate times time equals distance. So this will be 5 times x, and this will be 5 times x plus 20. And that'll be a total of 650. So we've got 5x plus 5 times x plus 20 equals 650. So 5x plus, I'm going to do some distribution. 5x, 5 times 20 will be 100 equals 650. So I have 10x plus 100 equals 650. I'm going to subtract my 100 from both sides. So I have 10x equals 550. Divide by 10, and x will be equal to 55. But we're not finished with this one because we have to find the rate or the speed of each car. So my first car is going to be 55 miles per hour. My second car is going to be x plus 20, which is 55 plus 20, which is 75 miles per hour. So this will be car 1 and this will be car 2.